So hello everyone, welcome to this new video of Kadane's algorithm. And in the last two videos, we have already seen some of the brute force approaches that were pretty good. But the problem of brute force approaches are, as you always know, that they take large time complexities. So the time complexities for both the brute forces, I will just write here once. So brute force one was uh, O of n cube, and the second brute force was around O of n square, right? So I hope you remember this. And today we are gonna see the real Kadane's algorithm that is there. So to find the maximum sum which a subarray gives, okay, from out of a given array. So here I have taken some examples like three sort of arrays where we are gonna find out the sum of these subarrays. Okay, so let's start this thing. Now tell me one thing, that do we need the subarray to also get printed here? We have already seen in the brute force approaches that we don't need any sort of sub arrays to get printed, right? We just need the sum, the maximum sum that a sub array gives out of a given array. That's all we need, right? So why do we care about the sub array that is giving the sum? We can just save the sum somewhere and that's it. And thinking of this concept, Cadence may would have released this algorithm where he would be saving just the sum. Okay, and how does he do that? Let's see here. So basically, what they try to say is they try to generate, they try to initialize two of your variables. So current sum, which will be saving the current sum, and one will be the maximum sum. These two, right? That's all. Now you see here that if I start from our first element, I start from the first element. So our first element is 1. Okay, my current sum starts from 0, so initialized from 0, and our maximum sum is gonna be initialized from int underscore min. You know that the minimum value given by the compiler is taken when we use this int underscore mean. Okay, so let's add this 1 to our current sum, and when we add this 1 to our current sum, it becomes 1. So 0 plus 1 is gonna give me 1. And okay, I will write it out so that it would be more easy for following. Okay, so 0 plus 1 would be my current sum. Now this 0 plus 1 is gonna give me 1, which can be replaced with int underscore mean, because int underscore mean would have a value, uh, very negative value. Okay, so obviously our this maximum sum, we have to keep a condition that if the maximum sum is greater than, is less than the current sum, then we have to change the maximum sum to that existing current sum. Okay, so currently we can see that our current sum is, yeah, 1, that is greater than obviously int underscore mean. So we will be changing our maximum sum to 1. Okay, now let's move on to the next one. By, I will just put, this was I, so currently our I will be here. So I will be here, iteration will be here. When iteration is here, I add minus 2 into our 1. So 1 minus 2 will give me minus 1. Okay, now this minus 1, again when you check, is greater than this maximum, the existing maximum sum. So you can see that no, because maximum sum is 1, your current sum is minus 1, obviously it's not greater. So what we will do, we will leave this as it is. So 1 is the maximum sum till now that we have got. Okay, now current sum is negative. Now see, you know that a negative current sum will obviously not lead me to a maximum sum, right? So when we subtract something and even we are getting into negative, then no hopes. So what we will do, whenever we encounter that our current sum has become less than 0, we are gonna change our current sum again to 0. Okay, so that's what we will do. Again we will make it 0. Okay, I hope you understood this particular concept. Then what we will do, we will again add our third, like the I, next I. Okay, next iteration. So we will add our 5 into it. We get 5. Now you see that 5 is greater than 1, so our maximum sum becomes 5. Okay, now again come to the next iteration. Next iteration comes on minus 3. So 5 minus 3 is gonna give me minus, is gonna give me 2. Yeah, so obviously there is no such possibility that 2 is greater than 5, so leave it. Again I comes here, 2 plus 4 gonna give me 6. So 2 plus 4 gives me 6, so my maximum sum becomes 6. Okay, again gives me 6. Now again see, 6 minus 1 gives me 5. No, now I have 6, right? Again I add 6 in my 5 and that gives me 11. That gives me 11, which is the maximum sum that we got, right? So 11 is the maximum sum that we got. Now, which was the subarray that gave me this 11? That also you can find out from here. See, from where you have started it. See, from we became 0 here. We became 0 here and we started adding from here, right? So we became 0 at third iteration. That is when we got the negative sum, that is here. Now, then what we did, we added 5 in our 0. Then we added minus 3, right? Then we added 4, then we added minus 6, then we added 6. So there was no such place where we made our current sum again 0. That's why our array subarray starts from 5, ends at 6, right? So this is our subarray that gives us the maximum sum, which is 11. So our max sum given is 11. So that's what I'm trying to say. Basically, you don't need to print the subarray that is given the maximum sum. So why do we need to store even iterate with I, j and k and all sort of things, right? So okay, let's see one more example. Now see, this is our second example here. This is also an array. You can see that we have taken an array here. Just shift it down. Okay, so minus 2 minus 3 4 minus 1 minus 2 1 5 minus 3. I'll again the same thing. I'll first declare two variables, current sum and maximum sum. So current sum, okay, and max sum. Fine. Now current sum starts with yeah, maximum sum is obviously int underscore mean, and our current sum starting from minus 2. So minus 2 as it finds 0. Okay, 0 0 plus minus 2 gonna give me minus 2. Then again became 0 0 minus 3 gonna give me minus 3, again become 0. So till here we don't need to actually see also. So obviously we are gonna skip these two parts only. We are gonna start our current sum from 4. Okay, so that's what I'm gonna do. I will start from 4 itself so that my space is saved. Okay, so I start from 4. So 0 plus 4 gives me 4. My maximum sum also becomes 4. Got it? Again, let's come forward. I comes here. I becomes 4 minus 1, that is 3. Okay, maximum sum is still 4 only. Again, minus 2 I do. I get 1, right? I get 1. Let's continue. There is no such problem. Okay, so 1 plus again I have 1. So 1 plus 1 gonna give me 2, right? So again 4 is only greater. No chance of changing it. Then I see that I need to add 5 in it, and that gives me 7, right? So that gives me 7. Obviously, my maximum sum becomes 7. Now, if I come forward, I come to 7 minus 3, that is 4. Not required. My maximum sum is given from 4 to 5. That's it. Why do I include minus 3? My maximum sum is given in here only. Right, if I add these all things, see, it gives me 7. 4 minus 1 is 3. 3 minus 2, 1. 1 plus 1, 2. 2 plus 5, 7. Right. Similarly, here also, if you add everything, so 5 minus 3, 2. 2 plus 4, 6. 6 minus 1, 5. 5 plus 6, again 11. That's it. Right. So maximum sum is given by this particular subarray, that is 7. I hope you are understanding. It's really easy. Actually, it is easier than the brute force approach also that we saw in the past two videos. Okay. Then let's come on to the next and the last example, and then we will be moving on to our code. Okay. So here also we have something called current sum, maximum sum. Okay. Current sum minus 4 I can skip. I hope you can get that. I start from 5, maximum sum becomes 5, right? So 0 plus 5 gives me 5, 5 plus 7 gives me 12. Maximum sum becomes 12. 12 minus 6 gives me 6. Again, let it be 12. 6 plus 10 gives me 16. Got it. 16. Okay, 16. 16 minus 15. 16 minus 15 gonna give me 1. 1 plus 3 gonna give me 4. So no, nothing required. I got my maximum sum from till 16. Okay. So 5, 7 minus 6 and 10, that gives me my sum, maximum sum as 16. I did it really fast. I hope you understood. If you didn't, just reduce the speed and see. Because see, already we have seen the example. You need to make an analogy and continue in more such examples. I gave you 3 examples so that you can remember it. That really fits in your mind how Kadane's algorithm is gonna work. So this is what Kadane's algorithm is. Now let's see the code for it and try to understand how it is done. I hope you have understood already the code. So yeah, obviously first we are gonna get the our array, okay, input of the array. So input of the array, right? Then we are gonna declare our current sum and maximum sum. I told you that maximum sum declared from int underscore mean. You can declare from zero also. So I will do that. Don't worry. Initialization of the variables. Okay, done. Yeah, so let's make it int underscore mean so that you will also be familiar. Okay, done. uh, okay, so we need to include our bit slash std c plus plus dot h. Okay, done, and our int mean is catched. Okay, now we use our for loop. So this is the place where what we were doing there. Okay, so this is our for loop. In our for loop, what we have done is current sum. We are increasing the current sum with the first value of our array. Okay, and then we are comparing it whether it is greater than the maximum sum. So obviously the first value will be always greater. Okay, even if it is a negative value, it will be greater because our int underscore mean has a lots and lots of like it's a very big negative number, so obviously it will be smaller. Okay, so that's why our first value of our current sum itself will be catched by this. So first time the condition will always be true, okay, if you are using this int underscore mean. Okay, so keep that in mind. That's not a need to tell, but still you should understand. Okay, then we check our current sum whether it is less than zero. If it is, just make it zero again and restart the thing. I hope you are able to catch it with the example that we saw there. So it's really easy, right? So let's try to run it out and check for an example. Okay, so let's give it the size. Let's give it an example of this example. So the size is 7. 4 minus 4 5 7. So the size is 7 and minus 4. Then we have 7 minus 6. 7 minus 6. Then we have 10 minus 15. And at last we have 3. So that's it. So now you can see that our maximum sum we have got is 4 16. So that's what I wanted to tell you guys, that how does Gadane's algorithm really works. And so I guess one input we missed. So minus 4 7 minus 6 10 minus 4 5 also. Sorry, we skipped 5. I'll just restart it. So 7, the size we should give is 7. Okay, minus 4, then 5, 7 minus 6, then we have 10 minus 15, and last we have 3. So you can see our maximum sum what we are getting is 16, right? So that's what I was telling you, that it works really great. And the time complexity, obviously a single for loop. So O of n, and that's how our Kadane's algorithm is the most optimized approach for finding the maximum sum, okay, of an array, like the sub array. This is how Kadane's algorithm works. I hope you understood this very well. This is how we complete our Kadane's algorithm series. Thanks for watching this video. Keep coding. Bye bye.